Right. Good morning, everyone. Today is Thursday, March 20, 2025. This is General Chemistry 1, Section 72, Spring 2024-2025 semester, and the time is 10:20 a.m. We are still in chapter number 6, yeah? We finished slide number 39, and that was slide number 39 somewhere in here, slide 39. Slide 39, I was talking about the coffee cup calorimeter. Remember this coffee cup calorimeter? And I explained in more details. Now, slide number 40 here, it is an exercise to go through. Now, it says a lead pellet. Now, lead pellet, it means ersas, okay? Lead pellet, that means it's a piece of lead. It's a piece of lead, a lead pellet, having a mass of whatever. So that's the mass of the lead. So we know the mass of the lead in here, okay? So that's the mass of the PB, the lead mass, piece of, that was held at whatever temperature. So the temperature in here is the temperature of the lead, all right? That was the temperature of the lead. Now, it was placed in a constant pressure calorimeter, which means in here, of negligible heat capacity containing whatever milliliters of water. So now I know how much milliliter of water is in there. Okay, so you have the volume, let's say in here, the volume is equal to 100 milliliters, 100 milliliters. And in here you have a hot object, which is actually the PB, and the PB temperature was equal to 89.98 degrees Celsius, all right? All right, and it has a certain mass in here. It has a mass and it has a temperature. Okay, now what happened in there? They say take this one and put it inside. Throw it inside the solution, inside the water. So you put inside. So what will happen? The temperature of the water was the water temperature, and that was the initial temperature of the water. It went down. Was it? The water temperature rose from whatever to whatever. What do you think? There is some mistake, yes? Yani it went from here to there, yes? All right? So that's the temperature of the water. Now, it does make sense, because if I'm having hot object in here, it has high temperature, I put it in water, the temperature of the lead will go down, and the temperature of the water will come up until the temperature of the water and the temperature of the lead are the same, صح? يعني the final temperature is how much? The final temperature is 25.50, صح? That was the temperature of the water. It went from low temperature to high temperature, and that was the temperature of the lead. It went from high temperature to low temperature, صح? Yeah? Perfect. Now, what is the specific heat of the lead? Now we need to find in here the specific heat of the PB. What will be the specific heat for the lead? How can I get the specific heat? Now, remember one thing. The heat that is being lost by the lead is equal to the heat absorbed by the water, صح? Which means in here, if I want to continue and do my calculation, I can get the Q that is being absorbed by the water, صح? Okay. And the Q absorbed, now I'm talking about the water in here. The Q absorbed by the water will be equal to specific heat for the water, صح? Specific heat for the water multiplied by mass multiplied by delta T. Am I right? Yeah. Which means specific heat is how much? 1 calorie per gram per degree Celsius. Am I right? Yes? Because it's a pure water. Okay? And the mass, do I know the mass of the water? 100 milliliters of water, yani شو? It is how many grams? It is really mass of the water is 100 grams. it is equal to 100 grams. Now I know I multiplied by 100 grams. And then multiplied by delta T. How much delta T? T1 23, T2 25, yani it's going to be equal to how much? Delta T in here is 25.5 minus how much? 23.17. That's it. Now, when I do the calculation in here, I will obtain the Q, the heat absorbed by the water. And the heat absorbed by the water is the same heat released by the lead. صح? Now, the Q absorbed by the water in here, this will be Q absorbed by the water is equal to the Q released from the lead, which is equal to what? Specific heat times mass times delta T. Okay? But I don't have the specific heat. And also what they want, they need to find what is the specific heat. I'm sorry, yes, specific heat. They need to find the specific heat. So this will be equal. I know this value. This will be equal specific heat of the lead multiplied by the mass of the lead multiplied by delta T. How much is the delta T? Delta T is 25 point, that's the final temperature, 25.50 minus 89 minus 89.98. Yes? I'm sorry about this. Yeah, okay. Now I know the delta T. Do I know the mass? Of course, I know the mass is whatever grams. So I know the mass in here. I know delta T, and then I can obtain the specific heat of the lead. Is it clear? Okay, good. Sorry? 25?
Why 25 minus 89, not 25 minus 23?
In here, you mean? No, you have two different temperature. That's a change of temperature for the water, and that's a change of temperature of the lead. Okay, in here, for the water, and that's what I said. For the water, it is final temperature of the water minus the initial temperature. Okay, and it's gonna be what, positive or negative? طبعا positive. And the Q of the water of the lead is going to be minus the Q of the water, صح? Because it's releasing the heat. Now, how much is delta T for the lead? Now look at the lead. The lead was very hot, and then when you put in water, it turns down the temperature. And the delta T will be the final temperature, 25.50, minus the initial temperature, which is 89. Okay? Minus this will give me a negative value come in. Negative value multiplied by negative value, this will give me a positive as a value. Okay? But in reality, it is what? Releasing heat. Yeah? Now, that's a strategy, so I explained to you how it is done. Now, delta T, we know what's delta T. Now, they started with the Q for the water equal to specific heat times mass times delta T. All right? And delta T is T final minus T initial. Now, when you look at the Q for the water, Q for the water will be the mass of the water multiplied by the specific heat of the water, specific heat for the water multiplied by delta T. And that's what we have done it in here. There's a mistake in here, sir. Yes. I don't know which right and which wrong. Is it 25.50, okay, or the other one? Okay, so there is something given wrong in here, okay? Now, we got whatever the joules in there, but the Q of the lead is equal, notice in here, it's a negative sign, sir. It's the opposite sign, because one will absorb, the other one is going to release, and will be equal to the mass multiplied by the specific heat, which is in here, multiplied by delta T. Now again, delta T, notice in here 23.17. I think there is some mistake in here, because, well, I don't know which one, where is the mistake. You'll find it out later on, all right? So the final temperature, it seems it's not 25.50, It seems it is 23.17. Yeah. Now, once you do this, and then you will obtain the specific heat of the lead. Look in here, the specific heat of the lead is equal to how much? Specific heat of the lead is equal to that much in here, whatever joule per gram per degree Celsius. What is the specific heat for the water? 4.18, yani much higher. Okay. And the water, you have to give a lot of, it has to absorb a lot of heat in order to go by increasing degrees by degrees. But while the lead in there, when you give it a little amount of heat, it will actually, its temperature will rise very fast. Okay, that's it. That's the idea about it. It depends on the question, really depends. We can give you the table. Maybe we ask you for the specific. Which one? What do you mean?
For the water.
You should know it, and it is already in the periodic table I give you in the exam.
Okay.
All right, done. Now, some heats of the reaction. When there is any reaction, we have several types of reactions. Several types of reactions. Several types of reactions in here. It means you can look in here. You don't have to memorize anything, but just work it out. When you talk about heat of neutralization, Shiani neutralization, what does neutralization? Acid and base will give me salt and water. Yani I'm having a container containing acid. I don't want this container to contain acid. I want to destroy all the acid. I will add a certain base. Hide your mobile. I can see it. Okay. No mobiles on the desk, please. Okay. None. Hide it, and turn it off. Okay. Now, heat of neutralization. Now, acid, strong acid in here with a base will give me salt and water. Now, notice in here, this reaction is exothermic reaction. It will give some heat. Yeah. Always the acid plus base will give me some heat. That means heat is going to be released. Heat of ionization. What does it mean? What does ionization mean? Ionization, that means I'm having a substance and I want to turn it into ion. And that's why I say ionization. Now, if I have a substance and I want to turn it into ion, it means I have to take what? Electrons from it. How can I take electron? Is he going to give me electron easily, or I have to take it by force? I have to take it by force. That means I have to put some energy. Yeah. That means who is getting the energy? The system, which means the system in here is endothermic. So now in here, for example, ionization. You have water, split it into ions, into H plus and OH minus. You have to put some energy. Without this energy, you cannot you cannot split the water to H plus and OH minus to get the water ionized. Heat of fusion. Heat of fusion. Get ice, a piece of ice, okay? And then you want to change it to liquid. That means you are actually, what you're doing in here, you're fusing. The technique is called fusing or fusion. You are fusing. That means what you have to do, you have to give it some energy. It will take the energy and it start melting. Yeah. So again, it is endothermic reaction. Heat of vaporization. Now, vaporization, that means I'm having water, liquid, and then I want to evaporate. How can I evaporate? I have to give it a lot of heat in order to bring every molecule. And every molecule of water should absorb the heat. There is a pressure above it. There is the air above it pushing down. That means if I am pushing down on something and I want my fist to go up, that means I have to give it a lot of energy to push out any obstacles. Yeah? By pushing up, that means the amount of energy needed to actually evaporate the water will be very high compared to the amount of energy when I want to melt a piece of ice, because the piece of ice is a solid on the ground and it turns to water on the ground. I'm not going to ask him to fly out, okay? To ask something to fly out, that means I have to give him enough energy to be able to fly. Is it clear? Now, what you can see in here, you can see the big difference, 44 kilojoule of reactions. Now, if I'm having whatever reaction taking place, and if this reaction is exothermic reaction, it should show a negative sign. That's the delta H. We will talk about it later on. If it's endothermic reaction, it will be a positive sign. Now, this is one other example. A quantity of whatever gram, whatever هيدا شو هون? There is something missing, صح؟ milliliters, yeah? Whatever milliliters of whatever molar concentration of the acid. Now, always in chemistry, when I give you a certain system and I say milliliters and its molar concentration, what can I get from here? Exactly. Immediately, when you have something like that, multiply this by that, yani volume multiplied by number of moles, and this will give me the number of. Now here I will also obtain the number of moles of NaOH. Is it clear? I don't have to hold two values together that they mean this for the same thing. I will get them together, get one information instead of two. You understand? Yeah. Now, the idea in here, so a quantity of yani one. Constant pressure, yani the container is open to the air. The pressure in the solution is equal to the pressure outside. That's why constant pressure. The initial temperature of the HCl and of the NaOH solution when you started with was equal to that much. Now what I'm having in here, I'm having T1, صح? And the final temperature when things are reacting, acid and base will give me salt and water. I'm stirring, the temperature keeps on going higher up to a maximum. How much heat is going to be evolved per mole, not per grams, per every 1 mole. We know the number of moles in here, صح? So whatever I'm going to obtain, whatever heat I'm going to obtain, I divide by the number of moles of HCl, and this way I will get whatever calories per mole. Okay? Now, what we've got in here. Now, here they're telling me, first of all, if I want to get Q, Q is equal to what? Specific heat multiplied by mass multiplied by delta T. Delta T, yes? Now, do I know the mass? Of course. What will be the mass? Okay, the mass, شوفوا, I'm having 100 milliliters of HCl, 100 milliliter of NaOH, yani I'm having 200 milliliters. If I want, but this is milliliters. If I want to know the mass, that means I need the density of the solution. If you don't give me the density of the solution at the end, I cannot find the mass. Huh? But here they're assuming that the density is equal to what? To 1. Yeah? Okay. So here they say that assume that the densities and the specific heat for the solution are the same of the water. Yani density is that much and specific heat is that much. You understand? That's for assumption. Yani practically they give me the specific heat, which is 4.15, 4.18. Yes? And what about the mass in here? How much will be the mass? This will be 100 milliliter plus 100 milliliters. Huh? And this will be actually equal to 200 milliliter, which means it is equal to how much? 200 what? Grams. So, because density is equal to 1. Now I know that the mass is 200 grams. Now the temperature, what will be the temperature? It went from where to where? It went from 22 to 25. Now I can get the delta T since I have both. So I know this, I know, and I know this. Now I can get the Q of this reaction, and it should be negative, definitely. Why it is negative? Because it is an exothermic reaction. The temperature went up. Now, once I find the Q in here, then I divide by how much? By the number of moles of what? Of, let's say, HCl. And this will give me whatever kilojoule per mole. Is this okay? And that's what they want to know. Per mole they want. All right. So let's see what they have done. Maybe they do it in different way, but I prefer to do it in this way. All right. Now, but you can do it also in any way you prefer. Now, let's have a look in there. I'm going to start of the solution. That's what we started with. And we say the Q of the solution, heat actually released from the solution, is equal to the mass. Now here is the mass. Yani the mass, add both of them, yani 200 milliliters, multiplied by the specific heat of the solution. Specific heat of the solution, multiplied by delta T, and this will be the value in there. Okay? But because the reaction is exothermic, that means Q is going to be negative, and that's a Q. Now, if you want to be per mole, but this is actually released per 200 grams of the solution. But if I want it per mole of what? I have to specify per mole of HCl or per mole of NaOH. If it's per mole of HCl, I divide this one. If I divide it in here by the number of moles of HCl, I will get the value. It's going to be the same because the number of moles of HCl and NaOH are the same. Okay? But maybe they have done it in different way in here. Now, from molarities. Now, again, from molarities, we know volume multiplied by molar concentration. This will give me the number of moles of HCl actually. All right. Now, heat of neutralization. So what they did in here, they took the Q, which they found in here, and they divided by the number of moles of HCl, and this way they obtain 56.2 kilojoule per mole of what? Of HCl, or per mole of NaOH in this case. Is it clear? Good. Now, we've got what's known as enthalpy of formation. Now, just pay attention in here. There is something which is called formation. If I'm having a certain or thermochemical equation, A plus B will give me C, and we have in here delta H of the reaction, because it's a chemical reaction. We write it delta H of reaction. But also I can put a not in here, yani 0. And this not means a lot in there. So delta H in here will be equal, for example, 170 kilo. 170 kilojoule. You see the unit in here? Kilojoule. Okay. The not in here, when I say there is a not in there, this not in there means under standard condition. Under standard conditions. And the standard conditions in here are the following. When the temperature is equal to 25 degrees Celsius and the pressure is equal to 1 atmosphere. Yani when I say not, that means that's how. Now, the way I read it, delta H not of a reaction. If I want to read it correctly, I would say standard enthalpy change of the reaction. You see how I went? Standard enthalpy change of reaction. And the standard enthalpy change of a reaction is in kilojoule or kilocalories, but not per mole. Okay? Done. All right. Now there is another term, which is the delta H not of formation, delta H not of formation, and that's now not of reaction, but it is of formation. And again, we read it as follows in here. We say standard enthalpy change of formation. standard enthalpy change of formation. All right, so that's how we read it. Delta H not formation, that means formation of a certain compound under standard condition. Formation of a certain compound under standard condition. Okay, what does it mean in here? That means you have a compound. How can I form a compound? For example, if I say I want to forming, for example, H2SO4. H2SO4, صح? I'm forming 1 mole. If I want to form 1 mole, I need to form it from its element in their standard state. Okay? Yani, I should have hydrogen, but the hydrogen, there is no H. It should be in form of H2. Plus sulfur, but the sulfur, I keep it maybe S. Plus oxygen will be O2, will give me this one. So you have element plus element plus element will give me this compound. You understand? So I form a compound from its element, from its element at their standard state. Yeah? And that's what we say formation. Now, if I look in here, delta H not formation of oxygen, how much will be? 0. Why 0? Because you're not forming oxygen. It's already there, صح? Okay. Okay. Now, carbon. The carbon has got 2 types of carbon. There is carbon which is in form of a graphite, and there is a carbon as a diamond. But in how does the carbon exist in nature? As diamond or graphite? Graphite. Yani delta H not of the graphite, that means that the standard state of the carbon is graphite, is equal to 0. Delta H not formation of O3, it's not equal to 0 because ozone, it's not the actual element in nature. It is equal to a certain value. And that of the diamond is equal to a value, and so on. Is it clear? Yeah. Standard enthalpy change formation or delta H not formation for Na is equal to how much? 0. Yani standard enthalpy change formation of any free element is equal to how much? 0. And we're not going to give it to you at all. We will not give you this at all. Okay? حدا يفيقه. Wake him up, please. Wake up, wake up. منيح ما بحكي قصص. Okay. Now, some standard enthalpy of formation. Now, you don't have to memorize anything in here. We have to give the standard enthalpy change of any compound, not any free element. Now, notice in here. Okay. Look at the Ca. Ca is a free element. That means 0, صح? Okay. صح النوم. Okay. Free element is 0. Cu is 0. Yes, and so on. You can see it in there. O, it's not, okay, O2 is 0, but O is not 0. You understand? So standard enthalpy formation of any free element is equal to 0. Is it okay? Yeah. Now you have a table. You don't have to memorize anything from the table, but let's go in here. Let's go through this one. Enthalpy of a reaction. Yani, if somebody will give me a certain reaction, AA plus BB, and this will give me CC plus DD. And they're asking me about the delta H of reaction. I'm asking for delta H not of the reaction. That's a reaction. So what I can do in here, you have to memorize this very easily. I start off of the substance D. minus, now I go to the reactant, minus A multiplied by the delta H naught formation of substance A minus B multiplied by delta H naught formation of actually B, formation of substance. To me because I should know it's equal to 0. Is it all right? Now, this way, once I have all the values, I add them in here, and then I will obtain the delta H naught for that particular reaction. Yes? Notice in here, delta H naught of the reaction will be C times delta H naught formation of C plus D times delta H naught formation of D minus A times delta H naught formation of A minus B times delta H naught formation of B. Is it clear? Yeah. Now, and or you can say delta H naught not of the reaction will be equal to sum of all the delta H naught formation of the products minus the sum of all the delta H naught formation of the reactants. Now you put it in there and you get it the correct way. There is a law in here which is called the Hess law. Hess law, Hess is a scientist, and that's the Hess law in here. It says when reactants are converted to product, the change in enthalpy, sure, a change in enthalpy, delta H, yeah? The change in enthalpy is the same whether the reaction takes place in one step or in many steps. You remember this, what we said before? What we call this one? We call this one a state what? State function. You remember the state function we talked about? Yes, yes. What? What was the state function? No, don't say yes then. Okay, so when you have actually, and we talk about if you have a hill in here and you have two people in there and they're going, this one is going straight up to the hill. You remember this? And the other person in here, it doesn't go up straight to the hill. Did we talk about it?
Yes.
It will go this way, this way, this way. And at the end, the amount of the energy they spend, this one and the other one is the same. And that's what we say it is a state function. It's a state function, which I explained before. So now, which means in here, if I have a chemical reaction, yani, for example, A going to B, and then the B is going to C, and then C going to D. Now, I have energy in here, E1, I have energy in here, E2, I have energy in here, E3, and so on. But if I'm having A going directly to D, how much will be the energy in here? This will be the sum of all the energy. You understand? Okay, so that's how it is. Okay, before you go to sleep, sign it. Okay, now let's have a look in here at some of the examples, some of the plot. Look in there. What I'm having in here, the enthalpy is going up. That's from the lowest value to the highest value. All right. Now, the reaction, now you have a graphite and a fahm. I'm burning the graphite in the presence of oxygen. Has the graphite a lot of energy? Yes or no?
Yes.
Of course, graphite, fahm, it has a huge amount of potential energy. That's why we burn it to take the heat out of it, to make our cooking or get actually warm. Now the energy in here is very high. If I'm going to burn it, as I'm burning this, what it will turn? It will turn to two things. It will, okay? It will turn to C plus O2. This will give me CO2. That's the final product. Huh? But the CO2, does it have a lot of energy in it or less energy? Much less energy. Otherwise, we would take it from the air and actually use it as source of heat. Now, this is a very low energy. This is a very high energy. And that's why the final energy is low, the initial energy was high, low minus high, it will give me a negative sign. That means when I burn the graphite, I get the negative. That means it's an exothermic reaction, all right? But if I look in here, the carbon in there, if you can notice, the carbon, when you burn it a little bit, this will give me CO, yeah? It's incomplete reaction. But if I put more oxygen to it, this will go into CO2. Yani I have two steps reaction. C plus half O2 will give me CO, and then the CO plus half O2 will give me CO2. If I add both together, so the CO and CO will get cancelled. That's the intermediate. And therefore, I will obtain carbon plus 1 O2, because half and half is 1, and this will give me CO2. This is the final reaction, all right? And this final reaction in there, it will have a certain delta H not of this reaction, all right? Now, let's take an example in here, okay? I think I wrote something for some reason. Now, let's have a look in here. Calculate the, now pay attention, I will not repeat anything, okay? Just pay attention and I will make it very easy for you. Calculate the standard enthalpy of formation of acetylene from its element. Yani you have the element and we want to find the delta H formation of acetylene. Delta H not formation of the acetylene, C2H2, and that's what we want to find in here, yeah? Can I say, can I use delta H not formation or delta H not reaction? What do you think?
Formation.
Why? Can I say reaction or formation? Formation, definitely, because I am forming 1 mole of the product, huh? That's if state, okay? That I cannot use formation. So every time you're forming something, you form it from scratch. That means from its element in their standard state, okay? Now, the equations for each step of the equation for each step is this much. Now, what they showed me in here, they say the carbon plus O2 will give me whatever, the H whatever and whatever, all right? Now, I'm going to solve it in a different way in a certain different slide. I hope that I took this slide in there. They are the same slides, huh?
Yes.
Okay? Okay. Now, I took them in here, so to explain. Now, look what I'm going to do. Now, in here, they give me 3 reactions. Reaction number 1, thermochemical reaction. They give me another reaction, number 2, and a third reaction, number 3. I labeled 1, 2, 3, so these are called what? Thermochemical equations. But now the question in here is he wants me to find the delta H not formation of reverse the sign of that equation. You finished with the attendance sheet? Just tick your name and pass it, please. All right. Now, rule number 1 of the manipulation. What was the manipulation in Arabic? Talayab, of manipulation. Okay, rule number 1, if you reverse the thermochemical equation, you must reverse the sign of the delta H, yeah? Rule number 2, if you multiply or you divide the thermochemical equation by any coefficient, you have to do the same with the delta H, yeah? Rule number 3, if I want to cancel anything, any component or substance in the thermochemical equation, they must have the same physical state. Yani H2O liquid, if I have H2O gas, I cannot cancel them. All right, so that's the rules in there. Now, look what I'm going to do. I have 3 equations in here, and I need to end up with this one. What I do, personally, I will take the carbon in here, I give it a circle, yeah, like a sign. And hydrogen, I give it maybe a square. And C2H2, I give it a triangle. Now I go through each equation. Now this equation, what I have, do I have carbon? I can see the carbon in here, صح? Hydrogen, there is no hydrogen, no C2H2. Okay, شكرا. No C2H2. Now I go to the second one. Is there carbon? There is no carbon. There is only hydrogen. So the hydrogen, I put it as a square, yeah? No carbon, but hydrogen, no C2H2, no acetylene. If I look at the third equation, no carbon at all in here, no hydrogen at all, but I can see only what? C2H2. Is this correct? Am I missing anything? No. Now I'm going to see what I can do in this case. I need to do some manipulation with the 3 available equations in order to get into this equation, final form of this equation. You're leaving? Okay. Okay. Now, it means, in other words, I want to get rid of all the oxygens. Huh? I don't want to see oxygen. I don't want to see CO2. I don't want to see H2O, and that's it. I don't want to see anything that is not being labeled. Anything that has not been labeled, I'm not going to have them in my final equation, and I want to cancel them. Now, another thing in here, where is the carbon? You have the chemical equation, reactants and product. The carbon is a reactant, صح? That means the position of the carbon is correct on the left-hand side. The position of hydrogen, it is reactant. It is correct on this side, yeah? But the C2H2 should be on the other side. Yani I have to move it to the other side. You understand what I'm doing right now? Okay, perfect. Now, look what I'm going to do now further to start my problem in here, solve my problem. If you have calculator, you can actually get your calculator, give me the values if you want numerical values. Otherwise, I will go as it is. Now, what I'm having in here, I'm having 1 carbon, but I'm having in here how many, 1 carbon, and I'm having 1 oxygen in here. In here, I'm having how many oxygen? I'm having how many oxygen in here? Half oxygen in there, okay? I'm having half of the oxygen in there. Now, and here I'm having 5 of the oxygen. Now, first of all, I would say in there, let me get rid of which one you want? CO2, and where is CO2? CO2 is in here. Actually, I'm going to say reverse equation number 3. Reverse the equation number 3, and this will change to a new equation, which is equation number 4. Yeah? Now, and the equation number 4 will be what? 4CO2 plus 2H2O. I'm not going to write liquid or whatever. And this will give me 2C2H2 plus 5O2 And the delta H will be equal to how much? Plus 2598.8 kilojoule. Finished. Now I have another equation. Now look at the equation in here and look at the equation right in there. How many CO2 I'm having? I'm having 4 CO2. In here, that's the only way I'm having CO2, صح? Now, if I say now, take equation number 1, okay, equation number 1, and multiply it by 4. I can do it, yes? So what will be in this case? This will give me an equation number 5, a new equation. Now I work with equation 3. Now I'm working with equation 1. I work with the equation only once, all right? Now, and then this will give me equation number 5. And the equation number 5 will be 4 carbon plus 4 oxygen. And this should give me 4 CO2, 4 CO2, yeah? And in here, the delta H will be equal to how much? Yalla.
39.
A day. This multiplied by 4. How much? Quickly, please. Huh? 1,500?
74.
74. Okay. Now, what I'm having, look in here, I'm having this and that. Now I would say, take equation number 3, add it to equation number 5, and then I obtain an equation number 6. And number 6 equation, what will be in here? If I add them together, what I'm going to obtain? Number 3, what is the number? Not here, number 3. There is, shouldn't. Okay, wait a second. Wait a second. Where is the CO2 we got in here?
It's like number 4.
Number 4. Okay. This number 4. Equation number 4. 4 CO2 and 4 CO2 will get cancelled. When I add them together, I will get what? 4 carbon plus
Plus 2 H2O.
4.
4O2.
Wait a second, please. 4 carbon. Now, 4 O2 in here and 5 O2 in here, remaining how many O2 on this side? 1 O2, صح? Yeah. Now, remaining will be 4 carbon from there. There is no other carbon. Plus 2 H2O plus 2 H2O plus the 2 H2O. And this will give me 2 C2H2, okay, plus 1 O2. And this delta H will be equal, yalla, add them together. How much will be equal? A day? 1024 kilojoule. Finished. No. But this is equation number 6. Now, خلصنا من الكل. Equation number 6. What I'm having in here, I'm still having the water, صح? How many water I'm having? 2 water. Now I would say in here, let me take this one and I say, take equation number 2 and multiply it by 2, and this will give me another equation number 7, صح? What will be number 7 in here? What will be number 7? It will be 2H2
Plus 2 plus O2.
will give 2H2O. Can you give me the corresponding delta H in here? How much will be? Negative 571.6 kilojoule. 500. Make? Now the next step in here, I'm going to say, take equation number 6, add to it equation number 7, and this way I will obtain equation number 8. Equation number 8, notice in here, I'm having 1 O2, and that's 1 O2. Two water, they get cancelled. When I add them, remaining will be 4 carbon plus 2 H2 plus 2 H2, and this should give me 2 C2, 2 C2 H2, and the corresponding delta H will be equal to how much? Yalla? 453.2. Perfect. Is this the right equation? No, because the correct equation, 2 carbon plus 1 hydrogen will give me that much. Now, take the 8 divided by 2, صح? And I will obtain equation number 9. Yes? When you divide by 2, you get 2 carbon plus 1 H2 will give me C2H2. And divide this one by 2, what I obtain in this case? Yalla. 226.6 kilojoule. Finished. Per mole, طبعا. Because how many moles I'm forming? I'm forming only 1 mole. And that's exactly what I'm going to obtain. Adetolite, 226. I hope that we did it correct with the things in there. 226, ما بعرف إذا مظبوط. 226 point whatever. Perfect. Yeah? I did manipulation. I did it my way. You can do it your way. Anybody can do it his way. You play with the equation, change the position, use the 3 manipulation rules, and find out the final one. Which one do you think is easier? This one, when we do the manipulation, or when we go through whatever known, you remember this one, what we did with the delta H knot formation? Remember or this one? Which one is easier? طبعا this one. Okay. If you are lucky, we can give you an example on this one in the exam. If you are unlucky, we'll give you the other one. Now here they give me 3 equations and they ask me for the 4th one. We might give you 2 equations and ask you for the 3rd one. We might give you 5 equations, or they might give us 5 equations. That means the time will be longer and longer. Yes. Now this is the manipulation of the rules in here, and we move a little bit further, and in here that's the final result of what we have done in there. So this value means that when 1 mole of the C2H2 is synthesized or formed from 2 moles of carbon and 1 mole of hydrogen, whatever, okay, 2 to 6.6 kilojoule of heat are going to be absorbed by the system. Okay, now the thermite reaction involves aluminum and iron. So aluminum and iron 3 oxide, when you react together, this will give me aluminum oxide, or we call it alumina, and 2Fe. This reaction is highly exothermic. That is, it gives a lot of energy in that. And the liquid iron, now notice in here, you obtain a liquid iron form, is used to weld the metal. Now, once you have this reaction, if you have 2 metals, iron, and you want to weld them together, then you can use this reaction because it gives a lot of electricity. And usually they use this one when they have the railway train. You know, the rail of the train, if they got cut somewhere, they want to do it, and they do it using the system. Now, calculate the heat released per gram of aluminum, yani how much aluminum per gram of aluminum reacted with whatsoever. Yani we want to know, okay. And they told me the delta HF for the Fe liquid is that much. They give me the delta H not formation for Fe liquid. But delta H not formation of Fe solid is how much? Bravo. It's 0. They give me this one. Now, what they do in here? Again, delta H not of the reaction. You know what's the reaction in here, all right? Remember the reaction? 2Le plus Fe2O3 will give me that much, okay? I cannot remember it completely. But again, what you do in here, you will go as 1 multiplied by delta H not formation of Al2O3, they should be given to us, plus 2 multiplied by delta H not formation of Fe liquid, minus 2 multiplied by delta H not formation of Al solid, which is 0, minus 1 multiplied by delta H not formation of Fe2O3. Now it also should be given to us in there. So that's what we got. Delta H not formation of Al2O3, delta H not formation of Fe liquid, of aluminum solid in here, and of this one. Once everything is given, aluminum solid is equal to 0 as delta H naught. Now, when you do the calculation, you will get the amount of heat that is being released. This huge amount of heat is able to melt the steel and get them close, welded together. Okay? Right. Now, we don't need this one. Now, thank you. Enthalpy of a solution. What is the enthalpy of the solution? طبعا we're talking about enthalpy change of a solution. مش enthalpy of a solution. Enthalpy change. Enthalpy change of the solution. شو يعني enthalpy change of the solution? Temperature change means the final temperature minus the initial. Enthalpy change means the final enthalpy minus the initial. Who has the enthalpy change? Who has the final enthalpy? The product. Who has the initial enthalpy? The reactant. Yani practically, the delta H of the solution is the delta H of the delta H of the solution is equal delta H of the product. Product minus delta H of the reactants. Okay, let's put it this way. All right, minus delta H of the reactants. That's the delta H of the solution. Now, These are some examples, and you don't need to actually memorize anything from there. All right, so don't worry about this one. Even you don't have to worry about this slide as well. Okay, so don't worry about this slide at all. And the last slide in there, you know, when you have, okay, they have some steps in here. If I'm going to go from this into there, that means I have to go through this step, and then from this step to this one. Remember, we're talking about state function. Remember the state function? If it goes in there, this will absorb maybe some energy. This will absorb 788, and going from here to there, this will release that much. That means finally, if I take minus 784 minus and the difference between this and that, it should be exactly equal to 4. Yes? Whether you go in one direct path or through multiple paths, that, okay, the amount of energy is going to be the same. With this, we finished chapter number 6. Mike, is it 6? Okay, we move to another chapter, and this is, okay, we have a few more minutes. At least we can start with a new chapter, yes? Okay, start with a new chapter, and this will be chapter number 7. How many chapters you have? 10?
8, 9, I think.
Are you sure? I think 10. I saw 10. 10. There is chapter 10 in here as well. Okay, good. Now,
Good.
there used to be 12, by the way. Okay. 42 slides. Not bad.
كمان calculations دكتور.
أكيد. أكيد. Right. Now, quantum theory and the electronic structure of the atom. Did we talk about the 1s2, 2s2, 2p6, and so on? We didn't. Okay, so that's all about it. All right. Now, quantum theory and the electronic structure of the atom. Now, just because we have few more minutes, let me give you just an introduction, and at least we started with this chapter. If I'm having an atom, what it means in there? When you have an atom, it means we've got actually nucleus. You have the nucleus, and you have protons, and they are positively charged, and you have neutrons, which are zero charged, and there are some shells around, and there are some electrons on the shells, and I write it as E minus. The number of electrons is equal to the number of protons, and that's why when I have an atom, the atom is a neutron, because the number of plus is equal to the number of minus. That means it is neutral, okay? Now, when we talk about quantum, شو يعني quantum? Quantum يعني quantity, means to do with the quantity. Quantum theory and electronic structure of the atom. Yani, in other words, if I'm having a certain atom of a symbol X, it has some electrons in there, and it has an atomic number. Let's say the atomic number is 24. 24 is the atomic number. That means when we say atomic number, it means in this case, this is equal to the number of protons and also equal to the number of electrons. Yani, this is the number of electrons of these atoms. When you have an atom, it means you have actually nucleus and you have shells. Now, the idea in this chapter, how I'm going to distribute the electrons in the shells. How am I going to distribute them? You have some shells in here. Okay, that's the nucleus. 1 shell, 2, 3, 4, 5, whatsoever, up to 7 shells. So you can have maximum 7 shells. And I want to know how we can place the electrons in the shells. Maybe I place 1 electron, a second one, next one, I place it in here, and I keep on going higher and higher. That's how we're going to accommodate the electrons inside the atom, all right? And that's, we call it electron configuration. Electron configuration. Configuration, that means give the place of every electron inside the atom in there, all right? Now, quantum means, as I said, means how much. Quantum, that means quantity, all right? Now, if I put, for example, at the door outside in this room, room A, another room B, another room C, another room D. These are what? Numbers or letters? letters. That means I'm giving letters to every room. صح? But if I want to give it as a number, I have to remove the A from this room and put maybe 1, or put 0, or put 2, put 3, put 4. That means I give it a quantity. That means it is quantized in there, which means we don't use anymore to label the classroom in here as letter A. I can put, for example, letter 5, number 5, or number 0. When I change it to number, the letter into numbers, that means I actually quantized this, the value, all right? We will talk about it next time. There are only 40 slides. We will finish them maybe in about 2 lectures. One more thing, your quiz will be on Tuesday, okay? Anybody send me an email to change the time of the quiz from here? Okay, don't send me any email to change, because we're not going to change. Okay, maybe from the other section. No, we don't change. اوكي اهلا، خلصوا منه قبل العيد، عيدوا بسطوا. اهلا اهلين. نحن 40. This is end 7 1. الله يعافيكي. اوكي